Alright, let's go. The goal of today is to demystify pointers. Pointers and references. The two main reasons why people in general dislike C++ and or think it's a really hard language. And it is. It is really hard. Actually, I would say like this. It's so easy to make mistakes when using pointers. I mean, that was what happened in the 90s. And the reason why C# and Java was created, basically, we needed something better so we could be more productive and not, reboot our computer all the time because we have screwed up some pointers, making the computer completely blue screen. Anyway, it's not that hard. I mean, we will talk about pointers and what it is, and references, and we will see some usage of it, why we need them. So basically, let's start with this. A pointer, what is it? Nothing but a variable containing an, it should say an, memory address. Memory address, I think. So that's the pointer. Nothing more, nothing less. And what is a pointer? Okay, so we talked about memory, how memory is just a consecutive, a lot of bytes after each other, and each byte has an address. It's like your street. Each houses has an address, so that's how we can find, someone. You live at Test Street 45 or 49. So I mean, it's the same thing in our memory. If we have like 16 gig of memory, we have memory addresses from 0 to 6. Anyway, and I mean, our variables, they live at certain locations in that memory, on that street, so to speak. And that's how memory works. Anyway, so let's then let's start with the pointer then. Okay, start here. So we have t. We give it a value of, let's say, 12. So t then, I will call this t, has the value 12. And I mean, t will be stored somewhere in on that street. It has to have a street number. And actually, since int is 4 bytes, and int is 4 bytes, typically doesn't have to, but if we are compiling on the 32-bit system, it typically is. Anyway, this is okay. So it uses these 4 bytes then combined to store an integer, right? Okay, let's create another variable, and let's say this is a pointer. It doesn't have to be named pointer. I'm just using it because of that. Okay. Okay, so now we have, what do we have? We have a variable which is called pointer t. Okay, so it's typically, it will be stored here. I mean, this is t, right? T starts 4 bytes, and then after the 4 bytes, the next variable, and that's the pointer t. But the thing is, inside this variable, what are we storing? What are we storing? We could do this. If we do this, I think you will understand we will store 12, right? Now it seems, okay, you can't do that. Yes, I can. but I need to typecast it. But now this is fine. Now we store in 12. But instead, let's store, instead of storing the house, so to speak, or a copy of the house, which is what we're doing. I mean, we are storing 12 here and 12 in here. As you can see, we are storing 12 at 2 locations. So instead of that, let's store the address where the original t is stored. That's what we're doing. We are using the address of operator. So we are getting the address of, and what is the address of t? It's 10,004. So now, I think we, sorry. Oh, that was really hard. Okay, this is exactly what we're seeing here. I mean, the numbers are not correct, probably, but anyway. And now, let's say we want to modify this value then. Oh, it's so easy to say. You just, yeah, we can modify it that way, absolutely. But we could also, the thing is, what can you do with a pointer? You could do things like this, actually. And sometimes we do things like this. So now the address will not be 10,004, but it will be 10,005. I mean, we use these kind of, or we could do things like plus equals 50. And now it will be, if it was the original, it now will be 10,054. The thing is, as you can see, this is just like any other variable, right? And we can change, we can modify the value inside it. What we're doing now, we're actually doing something called pointer arithmetic. And that's one of the things that makes C++ stand out. Not just, it's more complex and hard to use, but also you can do magic. You can do so performant things with pointer arithmetics. Anyway, just because you can doesn't mean you should. Anyway, let's use pointers as I intend to when I try to teach you this. So what we do is we use the dereference operator like this. And what we're saying now, we are saying when we set the variable, what we say is, okay, take whatever it's on this side and put it into the location that's, you know, has the name or the location where this variable is being stored. Now, when we're using this, the dereference operator, we are saying, hey, don't set the pointer t. Pointer t, yeah, don't set this one. Sorry, it should be like this. We need to go back to the original, like this. You shouldn't, when you do the assignment, calculate what it's on this side, but don't store it in pointer t, but store it in whatever pointer t is pointing to. Oh, pointer t, pointer to. So what is it pointing to? It is pointing to address 10,004. All right, so we end up here and we are modifying this. As you can see, when we are using dereferencing, it's kind of like, okay, it's another way on the road. We have to, it's a level of indirection. We need to check and go one step more, so to speak. So let's just print this, and we can agree. Okay, so it did work. Like, come on. So, okay. Actually, I should I should comment this out. So this is all that's happening. All right, let's run it and see if it says, what should it say? It should say 13, right? We are printing the t. We are only setting t to 12. So how can it be 13? Because we have a pointer to t, and we are modifying whatever the pointer is pointing to. Ooh, okay. So when I mean, this is a stupid example. When is it ever used? Let's do a better example. So let's create a function. Actually, I thought I had the... No, I didn't have it. I mean, this one. This won't work, because whenever we call a function, the parameters are copied by value. That's it's always like this in C++. Always. It's not like, I mean, it's kind of the same, but we don't see it that easily in like C# or Java or anything. We do see it when using primitive data types, like int, floats, and so on. It works exactly the same. If you do this in C#, sorry, this and this, we will, when we get out and we print the RR, it will still be 12, because there will be a copy. All right. So what can we do instead? We could. The problem is, okay, so the problem is, so we have RR, and when we call the function, the value inside RR is being copied. All right, so it's being copied to a new location on the stack. Maybe, let's say, up here. I just need to, like this. So it's, all the parameters are always copied. And as you can see, this is actually called, what is it called? I, maybe? Yeah. So it's a copy. And when we modify it, modified bad, we modify the copy down here. And when we get back, you can see RR is, of course, never modified. So what can we do instead? We could instead of sending a copy of the value, because then we are modifying a copy of the value. That's no use. We could send the address of the memory location where we want things to be changed. So what we're doing is we are, let's see, I think it's called modify 2 then. No, it's modify. Okay, so into modify, we are sending the address of R. What does this mean? Yeah, the address of will be, the address of RR will be 10,004. So 10,004 will be put into the variable called I, right? Sorry, I. So this is I, and I contains the value 1004. So it's like before. And as you can see, it still holds true. Whenever there is a call to a function, the parameters are copied by value. But it's fine, because what we're copying is not the value. We are making a copy of the address. So the address, I mean, there are always new variables being stored on the stack whenever we call a function like this. So what happens is this. Now, when we are modifying, we modify by using the dereference, And the dereference will then, okay, so they don't want us to modify this. They want to modify whatever this is pointing to. Oh, it's pointing to this address. Okay, so then we should set 123 into that one. And when we get back, we have modified the original. Okay, let's talk about objects then. So we have paint bad, I should call it. So we have a house, and a house is a class. It has a name and a color and so on, and there is let me do this. There is a paint bad, right? And what we do in paint bad is we're setting the color. So whenever we get out of this, we hope that the house has gotten a new color, but it hasn't, because it's the same thing. It's not this house that is being passed into this function. It's a copy of it. I mean, that's so weird. But the whole house is being copied, and we take that for granted when we talk about integers and primitive data types. But it's the same for objects, and that is a big change or difference. I mean, from how it works in C# or Java or so on. When we create an object, we knew it, right? We knew a new hockey player, and then we send the hockey player. Actually, we will never send the hockey player. We are always sending objects in C# and Java by reference. So it is pointers, so to speak, but we don't see it the same way. Okay, so this won't work then. How can we make it work? We could, as I said, send the address to the house. Cool. So let's do that. I have prepared already. So let's send the address of my house. So my house, it will be stored somewhere. I don't know how it. Actually, it's the name, and here's the color. It's blue, was it? Yeah. So it's, let's say my house are these 3 bytes. So when we are sending the address of this, we are sending this address. And when we get into Paint then, we could do like this. So we need to dereference, because it's a pointer. So we need to dereference it to get to whatever it's pointing to. So I mean that house pointer now. House pointer is down here on the stack somewhere. Sorry, that's hard. Okay. And in that it says 10012. So we need to dereference it, and by dereference it, okay, 1012, let's go to here, and let's start do whatever we should do. Okay, so we should set the color then. And set color will change this to W, and when we get back, it's modified. I have no idea what the W is. What color is that? I have no idea. Anyway, let's let's go on. I mean, this doesn't look that nice. We can agree on that. And if we do like this, it will complain, because the dot operator has higher precedence than this. So we need, it's anyway. Doesn't look that nice. So instead, what we typically use when we are using pointers to objects, we don't use the dereference, but we instead often use the arrow. So like this. So with the arrow, we could access the things inside that object, functions or methods, I mean, or whatever it is, attributes. And I mean, we often do the same thing inside objects. You know, this is a special pointer. It's always there inside, so we could, I mean, yeah, so we could always, but we use the arrow then. So that's the kind of the same thing. Anyway, so as you can see, this is okay. It's nice, but it's not that easy still, because what we need to do, we need to remember all the time. Okay, so we need to send the address to it, and we need to either dereference, as use the arrow, and so on. Is there another way? Yes, there is references. So I'm going to start by replacing this with a reference instead, and then I will show you when a reference is not a pointer. I will explain. Anyway, so we could use a reference. And what is a reference? A reference is actually, you should see it as an alias. And when we are calling a function, as you can see, I'm calling paint2. And this paint2 function doesn't take a house. It doesn't take a house pointer, but it takes a reference to a house. So you can see that ampersand, it has different meanings wherever it is. So now it's it's on a third location, and it has a third meaning, you know. Anyway, so what this means is, we don't have to send the address, but it's kind of automatically fixed for us. I will talk about that. Let's look in paint2. So paint2 then. The thing about paint2 is that it takes a reference, and when it takes a reference, we could do house dot set color and it will work. So we don't need to use some kind of dereferencing or pointer or anything, but it's still modifying the same value. So the meaning of a reference is that this is an alias to this house. So it's an alias. Therefore, automatically it will modify this one. But the thing is, I mean, under the hood, without we noticing it, it is implemented as a pointer. So it's in a way, actually more than just in a way, actually it is syntactic sugar for us. So we don't have to use the dereferencing and so on, but under the hood the compiled code will be the same. So for this one and this one, it will be exactly the same. Anyway, when is a reference not a pointer then? There are some odd cases. I just want to, I mean, we could do things like, let me see, where is it? Yeah. No? I thought I had... okay, here it is. Okay. So we have this one. And we have this one. So what we have here, we have an integer I. We set it to 12. I'm just going to look and be sure I'm not already using I. I'm not. And we have a variable called iref, and it's of the type integer reference. So in this case, actually I could do things like, yeah, like this. Yeah, that's it. Let me think. Okay, yeah. Okay, so we have a variable and we set the reference to it. We set the reference value to 19. Anyway, and we set this. Yeah. All right. Let's see what happens. I mean, this will work the same. It's kind of a stupid example. So as you can see, I is 19. We have never modified. But the thing is about a reference is that we don't have to use, you know, the address of or anything. The thing about reference is that we need to assign it to a value. It's a difference between the first assignment and the next assignments, or how should I put it? Have a look at this. Now we are setting a reference to this variable, but I can't change the reference after it has been created. I can't set the reference to point to, in this case, J. And now I can't modify. I mean, if I now do, what do you think will happen? What do you think will happen? J will never be modified. I promise you that, because it's only the first assignment of an reference that is saying what's my alias. The next assignment will I mean, the next assignments will change the value. I mean, that's what we're trying to do. So what this will do, it will set I will be the same as J. I mean, when I did this, right? I did this before. I will do it again. Just like this. Here, I'm pretty sure you do understand that. Okay, so I will get the value I. Will get the value of 111. We agreed on that, but we had 1, 2, 3 then. So what happens if I do this? It will set iref to 13. It could never ever change what it's referencing to, but it will change the value. Anyway, this is, I mean, we seldom use references in this way, kind of. So we have a references something else in the same scope, and it's kind of a weird use case. But still, we're learning things about how references work. And believe me, I've seen bugs kind of this many times, where people try to reassign the reference instead of you can only change the underlying value of a reference. You can never change what it references. Okay, so let's finish this off then. First of all, pointers. Why do pointers exist? Pointers exist because we need them to be able to modify a variable when calling another function. So we have a variable and we need another function to modify it for us. We also use pointers for performance reasons, obviously. When copying by value, there will always be duplicates, or even more than duplicates. If we have a structure maybe of a couple of thousand bytes totally, the hockey player object, and we are sending it to a function and sending it to another function and sending it to another function. There will be multiple copies. And it's not just the fact that we are using RAM. We are also, the copying of the data will take time. So that's the two reasons. So why are we using reference then? Because this is so hard. We try to always use references instead of pointers because it gives us nicer syntax. Okay, that's it. I hope that explains some things about pointers and references. See you in the next video.